Hello, my name is Russell Hughes for Sunset Learning. I'm here to talk today about access lists and their applications and ways that we can use access lists. So first off, what is an access list? Access lists are simply nothing more than packet filtering techniques that we can utilize. Now, we can use it for multiple things, right? You're trying to match information within inside either a layer 3 or layer 4 header of a packet as it traverses the network. We can use this information to go through and determine what type of traffic goes from one subnet to another subnet, or from one interface to another interface on those routers if we wish. Some switches support access lists as well. What can go from one subnet to another subnet, or one interface to another interface that we use. We can also utilize access lists to do things like classification of our traffic. A lot of people utilizing an equality of service type of environment that utilize access lists to match traffic, like this is my voice traffic, and give it priority queuing. So, many different ways. We can also go through and assign an access list to our virtual terminal lines as well to say who can telnet or SSH into our routers. So, we're going to see a couple different things. We mentioned a couple types of applications that we can use an access list. We mentioned as far as applying an access list to our VTY lines and how we actually go through and determine who can telnet or SSH into that device. We can also assign an access list either inbound or outbound on an interface. As we transmit that packet through the router, that we can go through this filter to say what can and cannot pass. We mentioned some other uses. We mentioned things like classification of our traffic in a quality of service environment to be able to do things like priority or custom queuing or low latency queuing. We can do things such as our dial-on-demand routing. You see a lot of people utilizing this as like a VPN type of situation. In a VPN, we can determine what is interesting traffic and what's going to be sent through and encrypted on that network. And obviously, we can also use it for things like route filtering as well. Route filtering determines which subnets am I actually going to advertise outbound to my neighbors. Which subnets are we going to receive from our neighbors? Okay? You see a lot of route filtering when you deal with BGP. What are we learning from our service providers at any given time? I might want to go through and say, instead of learning 400,000 routes from a service provider, filter out everything except for a default route. Okay? And they show there are different types of access lists. First off, as far as the types of access lists, there are standard and extended access lists. A standard access list only looks at layer 3 information. So in this case, it checks the source IP address of the packet. And that's the only thing that we're looking for in that IP header itself. And from there, I either permit or deny the entire protocol suite. Okay? All of IP traffic is denied from that individual subnet or that individual user. As an extended access list, it allows us to look into not only the source IP address, but also destination IP address. So I know who you are and where you're trying to get to. We can also look into information into the layer 4 headers as well. Our TCP and UDP headers, and what port numbers are we allowing back and forth. Okay? So we can actually go through and just do things like denying specific applications as it goes through an interface as well. As you look in the access list, you'll see that they have both permit and deny statements. A permit statement obviously would allow that traffic through. A deny statement would drop the traffic, throw it away. Okay? As we apply an access list to an interface, we can apply it as either an inbound access list. As the traffic comes in on a router interface, we're going to evaluate to determine what will we route through to other interfaces. Okay? Anything denied would be dropped from that individual router interface. It can also be applied as it goes out of an interface in the router's perspective. So now in this case, we've done all of our packet manipulation. I've gone through and done things like a routing process itself. It's now sending out on this serial interface, and we have to determine now, can it be permitted to go out that interface or not. And as far as how to identify access lists, there are really 2 different ways to identify access lists. They originally started off with numbered access lists, and they show in this case right here standard access lists use a number from 1 to 99. They've also got an extended range as well from 1300 to 1999. We have extended IP access lists are from 100 to 199, and they also have an extended range from 2000 to 2699. We also have the ability to use now named access lists as well. And if you think about what the number does, the number is really telling me, A, what protocol is being filtered. These are specifically for the IP protocol. And B, is it a standard or an extended access list? So when we create a named access list, we're going to have to specify what protocol is being filtered and is that a standard or an extended list. As they show for a standard access list with those numbers of 1 through 99 and 1300 to 1999, We're only checking the source IP address of the packet. Where is it coming from? Typically, access lists like this would be used for things like permit and deny users to be able to telnet or SSH into the network itself, okay? Because we already know all the other information. I know that it's telnet or SSH. I know what the destination IP addresses are. It's somewhere to this individual router. So the only thing we really need to look into is the source IP address. Where is it coming from? Okay. Obviously, there are other things that we can use standard access lists for as well if you want to just permit or deny the entire IP protocol suite from a certain network. In an extended access list, it allows us to look at more information. Not just the source IP address, but now also the destination IP address. We can also do deep packet inspection as well. I can find out information like the protocol number. Is it TCP or UDP or ICMP or an ARP packet, EIGRP or OSPF? We can also look into information as far as the port numbers being used in the TCP or UDP header as well. So we can specify exactly which application is it that we're trying to match. And again, they show you access list statements used for extended access lists use numbers from 100 to 199 or from 2000 to 2699. As you go through an access list, you will see it is a linear function. Okay? What I mean by that, and they always call it top-down processing of an access list. We're going to go through as traffic comes into the interface. And in this case, they're talking about this being applied as an outbound access list on this interface, this Ethernet 0 interface that we're dealing with. So the first thing that happens, as a packet arrives at a router interface, I'm going to go through and validate, can I actually route that packet? Do I know the destination IP address, and do I know how to send that information? If we do have an entry in the routing table, it chooses an outbound interface. Okay? If I find the outbound interface that we want to go through, then we say, do we have an access list on that interface? If there is an access list on the interface, we've got to go through and test this packet based off of the access list statements that we have. If there's no access list on the interface, it just gets routed out the interface. Okay? So the net effect of not having any access list on the interface is to allow all traffic. Okay? As we said, when we go through and test an access list, we start from the top, the very first line in the access list. You'll see we now have sequence numbers and access list statements, and it starts with the lowest sequence number, working its way to the highest sequence number. Okay? And it goes through and says, does this packet match this particular statement in the access list based off a source and destination IP address, protocol, and port number? If it does match this statement, does this statement state a permit or deny? If it denies, I throw it away. Stop checking the rest of the access list. If I permit that type of traffic, it goes out the interface. Stop checking the rest of the access list. However, if it doesn't match that statement in the access list, it's on to the next statement in the access list at that point. Okay? Again, if this statement matches, if it denies, throw it away, permit, go ahead and route it. If it doesn't match, on to the next statement in the access list. Every access list in Cisco iOS eventually ends in what they call an implicit deny any at the end of it. Okay? The idea being kind of a security thing. Right? If I don't specifically allow that type of traffic, I'm going to throw it away. Now, access lists use wildcard bits, and they show you as far as wildcard bits what we're really trying to do. The idea being that a 0 in any bit position means I need to check that value for the corresponding address that we have. Okay? Make sure that it matches what we have in the address itself. A 1 means ignore it. So it's certainly, a lot of people get confused with the wildcard mask and the fact that they may potentially match an subnet mask. This does not have anything to do with a subnet mask. Simply bit matching criteria is what we're looking for. And I'm going to pause this for right here so that I can write some things up on this board to give you a couple instances of things that we can actually do. So again, if we go through and examine what that wildcard mask actually is for us, as we utilize it in an access list, you might look at it and it might say something like this. I want to match the 10.1.1.0 subnet. Okay? So in this case, what we want to say is I want to check the first 8 bits and make sure that the first 8 bits exactly match the 8 bits that are in this particular octet. So we're going to go through and say a 0 in this case. Remember, a 0 in any bit position means check that bit and make sure it matches the corresponding bit in the address. So with a 0, meaning all 8 bits are set to 0, I'm checking all 8 bits in the first octet and make sure it exactly matches what's in the first octet of the address. Okay? Likewise, we want to check all 8 bits in the second octet and all 8 bits in the third octet. However, as far as the fourth octet, I could care less what that value is. And in this case it says, if the source IP address starts with a 10.1.1, it matches this particular statement. Okay? Whatever they have in that last octet, I don't care about. Okay? Why I always mention that, in most cases people would say that this is the 10.1.1 subnet. Okay? Here's why I say a wildcard mask does not have anything to do with matching a subnet mask. I can actually use a wildcard mask to go through and say, I want to go through and match a 1 in the second octet. Okay? In which case my wildcard mask would be a 255.0.255.255. I want to ignore the first octet. I want to check all 8 bits in the second octet to make sure it exactly matches at 1. As far as the third and fourth octets, could care less what they are. Okay? So this matches any packet that has a 1 in the second octet of the IP address. Okay? Likewise, you could also go through and say, if I change that wildcard mask to a 254, for instance. Okay? In this case, what it's saying is I just want to check the very last bit of this second octet and make sure that the very last bit is actually set. Okay? Which would match any odd number in the second octet. Okay? So this has absolutely nothing to do with what a subnet mask is. And as a matter of fact, in most case scenarios, you would think that the idea of a router doesn't know what the subnet mask of any individual device. Okay? All they're looking at is the source and destination IP address in the IP headers that we're receiving as we send it across that network. So they show, as far as wildcard bits and ways that we can utilize these wildcard bits, if I want to check all 32 bits to exactly match a certain source IP address, I can go through and put in the IP address as 172.30.16.29 with a 0.0.0.0 wildcard mask. Okay? And in this case it says, let's check all 32 bits and make sure it is exactly that source IP address. Okay? They show another way of being able to write that. So instead of actually typing it out as a 172.30.16.29 with an all zeros wildcard mask, you can actually type it out as host 172.30.16.29 as well. Likewise, if you want to go through and match any number, we could write that as a 0.0.0.0 with an all 255's wildcard mask. Okay? Which we're essentially saying, ignore all 32 bits. It would match any IP address at that point in time. Likewise, instead of actually typing it out that way, we can type in the keyword of any and utilize that in our access list as well. So they show in this case right here, matching bits for all of these different subnets. So now in this case, notice they got, I know how to reach the 172.30.16.0/24 network. Assuming we also know how to reach the 17 and 18 and 19 and 20 and 21 and 22, all the way up to the 172.30.31.0 subnet. Okay? So there's 16 total subnets that we know how to reach. We're trying to match all 16 subnets at the exact same time. So what we're looking for in this case, I know in the first octet, a 172 matches in all of those cases. I know in the third octet, a 30 matches in all of those cases. So now what we're looking is, how do we get a range from 16 through 31? Well, in this case, if you write it out in binary, they're showing it in binary down here on the bottom of the slide, what you'll see is that from 16 to 31, the first 4 bits are the exact same. You'll see a 0001 in the first 4 bits. The last 4 bits will go from an all zeros, which is the 16, to an all ones, which is the 31. Okay? So it's all contiguous range. So what we're looking for in this case right here is to say, I want to check and make sure that the first, the second, third, and fourth bits of that third octet are as 0001 exactly. But I don't care what's going on within the last 4 bits of that particular address. Okay? So my wildcard mask in this case is going to be a 00001111 or a 15. Okay? So we're going to write that as a 172.30.16.0 with a 0.0.15.255. Okay? So we're saying, I want to check the first 8 bits, make sure it's exactly a 172. I'm checking the second 8 bits, making sure it's exactly a 30. And I'm checking the first 4 bits in this third octet to make sure the first 4 bits exactly match a 0001 for a 16. So now they go through and they discuss, they discuss configuring IP access lists and what are the commands that we need to be able to create these access lists. Okay? So first off, they tell us a couple of different guidelines, ways to really utilize access lists to your advantage in most case scenarios. And some of these are for good purposes. Okay? Some of them are about things like CPU and memory utilization that we have on the router itself, the speed it takes. Access lists do indeed take up CPU utilization, so they will slow down your router. So first up, we mentioned the idea of the access list number. If you're using numbered access lists, remember that that number actually indicates two separate things. It indicates which protocol is being filtered, IP, IPX, AppleTalk, DECnet, Apollo, Vines, and also indicates whether or not it's a standard or an extended list. Okay? They show, as far as access list placement, we can only have one access list per interface, per protocol, per direction. What they mean by that, I can have on every interface on my router, I can have an inbound IP access list. And on every interface on that router, I can have an outbound IP access list. Okay? But I can have no more IP access lists on that router at that point in time, because we've got already an inbound and an outbound access list on every single interface. However, every interface can also have an IPv6 access list, both inbound and outbound. We could also have an IPX access list, both inbound and outbound, if you're still using IPX. They show the order of the access list statements controls testing. Remember we mentioned that idea of top-down processing of the access list. They look at the sequence number from lowest number to highest number and just evaluate the statements in order. They show, for that reason, we want to place the most restrictive statements at the top of the list. If at the top of my list I say, let's permit all IP traffic, and then underneath that I start to deny traffic, well, everybody is a part of all IP traffic, so it's all permitted. So the deny statements underneath that wouldn't have anything to do with what's allowed through. Sure. There's an implicit deny statement as the last line of every single access list. So I need to at least have one permit statement. If all my statements are deny this, deny this, deny this, deny this, and then the implicit denies on the end, you're eventually saying deny all IP traffic. Okay? You need to create the access list and then eventually apply it to an interface. So you create it in global config, and then you go into the interface and apply that access list on the interface. Okay? And they show access lists filter traffic going through the router. They do not apply to traffic originating from the router. Meaning that as a packet traverses that router, comes from one interface and we have to send it to another interface, that's when we'll use those access lists. If I telnet or if I SSH into that router, none of that's coming to the router or from the router at that point in time. That would skip all access list statements on the interfaces that they're utilizing. Okay? Not to say that we can't apply an access list to those virtual terminal lines to say what people could telnet or SSH to or from. So they go through, they show us our access list commands and some of the ways we have to use to be able to create these access lists. First off, I go into global config, so I've typed in config T. Underneath here, I'll say access-list, and I'll specify one of your access list numbers, okay? Whether it's a standard or an extended list. In this case, they're going to show you eventually creating a standard access list to begin with. Once we created the access list with multiple statements, okay, there's typically multiple lines in this access list using the exact same access list number, eventually then I need to go into an interface. Underneath the interface, I will apply that access list as either an inbound or an outbound access list. So you'll say IP access-group, and then the number of your access list, and whether or not that's going to be an inbound or an outbound access list on the interface. So let's look at an example here. Okay? They're eventually showing a standard access list. Remember, standard access lists use numbers from 1 to 99 in most case scenarios. We also have that extended group range command that they've got as well. They show a couple different things about it. A standard access list, 1 through 99 for the number itself. The default wildcard mask is all zeros. Now, newer versions of iOS do not have a default wildcard mask, so you're going to have to assign a wildcard mask in the newer versions of iOS. They show, I can remove an access list by typing in no access list 101, removes the whole list from the router itself, throws it away. Okay? Eventually, after I create the access list, again, have to apply that as an access list on an interface. So here's a specific example here. I created an access list. I've got two different networks, actually three different networks. I got the 172.16.3 network over here, the 172.16.4 network over here, and some non-172.16 network up over here. Let's assume it's in a 192 addressing range. Okay? So they created an access list on my router, access list number 1, that permits the 172.16 0.0 with a 0.0.255.255 wildcard mask. So what they're saying is, I'm checking the first 2 octets to make sure that they're exactly starting with a 172.16. Okay? And since it's our only permit statement, even though it's not actually a part of the access list itself, remember we have that implicit deny at the end of all the access lists. Okay? So it would be like I created an access list statement that says access list number 1, okay, my second statement in this access list, is denying all other IP traffic. Okay? And they've taken that access list and they've applied it, in this case, to multiple interfaces. They apply it to Ethernet 0 as an outbound list. They also apply it to Ethernet 1 as an outbound list. So they've applied this access list in this direction and in this direction. Now, what this does is it allows only my own network. I can send traffic from the 172.16.4 network to the 172.16.3 network and back and forth. But we cannot send traffic outbound to the 192.168 network. And the reason for it is this. As we send traffic outbound, right, it's coming through, there's no inbound access list on Ethernet 0, and there's no outbound access list on Serial 0. So the outbound traffic works just fine. It's the return traffic that comes back through. Now it's got a source IP address of a 192 in that source IP address. So when it has to go out Ethernet 0 as return traffic, it says, let's evaluate this access list. Does your source IP address start with a 172? No, it doesn't. Then throw away that traffic. Another example in this case, a little bit different. Now that they've done is they create an access list statement where they're denying the 172.16.4.13 address, right? And notice it's an all zeros wildcard mask, so this one specific host is what we're denying. We're permitting then all other IP traffic. We're applying that on interface Ethernet 0 as an outbound list. Okay? So as traffic comes through, if I'm a 172.16.4.14 address, as it comes through and has to go out Ethernet 0, they'll say, is this your source IP address? No, it's not. Are you any other source IP address? Yes, I am. Then it is permitted to go out that interface, and it's allowed through. However, if this host tries to send information outbound to this subnet, again, it's going to say, are you this IP address? Yes, I am. Well, that's denied and throw it away. Remember we said you could even type that as access list 1 deny host 172.16.4.13. Our third example in this case matches the entire subnet. So we're looking to see, do the first 3 octets of the source IP address match as 172.16.4? If so, throw away that traffic. Okay? If it's anything else as a source IP address, permit the traffic. This allows nobody from this subnet to communicate outbound this interface. Okay? But if I'm coming from a different subnet, in this case like a 192 network, it's going to be allowed through with no problems. As an extended access list, we mentioned we can check more than just the source IP address of the packet. Now I have the availability to check the protocol. Is it TCP or UDP or ICMP or EIGRP or OSPF? I can look at the source IP address information and a wildcard mask for that as well. We can look for source port number. We can look at destination address and destination port number that we're looking for. We can go through and say if it's an established session, meaning that there's a TCP acknowledgement bit set on there. And I can also log that to syslog information for every single statement of that access list. Again, just like we saw before, I have to build the access list in global config and then eventually apply it to an interface using the IP access-group command. So they go through and give us examples, in this case, of an extended access list. Now we've got access list number 101, which is an IP extended access list. Remember we said using from 100 to 199 in most cases. They show we're denying TCP traffic from the 172.16.4.0 subnet with a 0.0.255 wildcard mask, so the entire subnet, to the 172.16.3.0 network with a 0.0.255 wildcard mask, meaning this whole subnet out over here, if it equals port number 21. Okay, so FTP traffic. We're also denying TCP traffic from the 172.16.4 network to the 172.16.3 network if it equals port number 20. Again, you've got FTP and FTP data that we're actually sending back and forth. I'm denying. However, I want to allow all other IP traffic. So I've created an access list statement, it's still a part of the access list number 101. My permit statement says let's permit all the rest of the IP protocol stack from any source to any destination. They eventually take that access list and apply it to our Ethernet 0 as an outbound access list. So under Ethernet 0, I said IP access-group 101 out. Here we see another example of an extended access list right over here. They've again created access list number 101 where they're denying TCP traffic from the 172.16.4.0 subnet to any destination address if it equals port number 23 or telnet traffic. And they're permitting all other IP traffic from any source to any destination. So they're denying just telnet from this network to anything out over here through Ethernet 0. They apply that on that Ethernet 0 as an outbound access list. We mentioned we also have the availability to use named access lists. And named access lists are just easier as far as administratively concerned. Right? The name of your access list can be why you're using the access list and where you're applying that access list as well. But remember, if you're using a named access list, you no longer have that number. And that number told us two things. What protocol is being filtered, and is it a standard or an extended list? Okay? So when we create a named access list, now when we go into global config, I'll have to say IP access-list, and then specify will it be a standard or an extended list, and then the name of my access list that I'm going to use. You will see that takes us into a sub-command mode. Okay? It'll show us that we're under config-extended NACL at this point in time, where we no longer have to keep on typing access-listener our number. Now we can just put in our permit and deny statements. Okay? So you go through and specify that. Again, just like you would see before, I have to build it in global config and then apply it to an interface. Okay? Now, we mentioned that we can also go through and utilize an access list on our virtual terminal lines, or our VTY lines that we use. Okay? As you telnet or SSH into the device, you'll see by default we typically have 5 VTY lines that can be used. You can create more if you wish. But in this case they show 0, 1, 2, 3, and 4 are our different VTY lines that we have on this particular router. Okay? If I want to apply an access list to say who can telnet or SSH into this particular device, I can use that, but I've got to apply the access list instead of to an interface to the virtual terminal line. So you'll see a slightly separate command that they utilize to apply that access list to a virtual terminal line. So in this case, they're going to go through, I'm going to try and set up an access list filter, and in this case, we're going to use a standard access list. Like we said, I already know everything else. I know that it's going to be for telnet, so I know it's TCP traffic on port number 23. I know the destination address would be some address of the router itself. The only thing I don't know is the source IP address that's allowed to be able to do that particular traffic. So we're going to go through and show you how to set these restrictions on here utilizing the access class command. Okay? So I'm going to go into our create our access list. I'll go into our virtual terminal line. So you'll say line VTY 0 through 4. And eventually then underneath the virtual terminal lines you'll type in access-class 101 in, or my named access list, the name of my access list and whether or not it's inbound or outbound. So here's our example in this case. They've created access list number 12, a standard IP access list, that permits the 192.168.1.0 subnet. Okay? So I'm checking the first 3 octets, make sure it's 192.168.1.0. They've eventually then gone into our virtual terminal lines and said access-class 12 in. So now it says, as far as people telnetting or SSHing into this particular router, they have to be coming from our administration network, and if they're not coming from that subnet, we don't allow them to telnet or SSH in. Now, a couple different things as far as configuration principles, some recommendations of what we would use for access lists in most case scenarios. We mentioned the order of the access list is extremely crucial. Okay? We said as we go through, we start from the top and work our way down that access list at any given time. So if we've got a permit statement up at the top of the list that allows my traffic, and way down at the bottom of my access list I've got something that denies that same type of traffic, The problem with it is I'm going to hit the permit statement up at the top of the list, and it's going to be gone through. I wouldn't even check the deny statement down on the bottom of that access list. Okay? That top-down processing being very important. Like I said, newer iOSs actually show you all of the individual sequence numbers for them as well, so that you can go through and edit that access list a little bit easier as well. So because of this top-down processing, we want to place the most specific test statements first. Okay? Meaning that if I have, let's say, a group of users, they're all on the exact same network, and I want to kind of signal out one individual user. I want to allow everybody to do HTTP traffic except for one individual user. I have to deny the individual user, which in that case is the most specific statement first, and then permit everybody else that we're going to be allowing. Okay? As far as removal of statements, they show no reordering or removal of statements. Well, that's no longer true. Newer versions of the Annex OS, or the iOS allows for us to be able to go through and use sequence numbers so that we can edit statements and remove statements from that access list. Okay? And they show, don't forget about the implicit deny all applied to the end of the access list. Okay? If my access list does not have a permit statement, I am essentially denying all traffic. They show where do we place them? Well, as far as access lists, generally speaking, you would say place an extended access list as close as possible to the source. Okay? If what I'm trying to do is I'm trying to deny this individual user from being able to get to this subnet out over here, why would I want to throw that traffic out as it left the interface on router B? Okay? You've utilized all the bandwidth through your WAN link at that point in time to throw it away on the other end of that WAN link. So it's much easier to go through and say, as we match that traffic out over here, I can throw it away here so that I don't waste the bandwidth of the WAN link in the middle. As far as the standard access list, they show place that as close as possible to the destination. And the reason for that is a standard access list only checks the source IP address. I have no idea where you're going. So if I want to go through and just block that user from getting anywhere out of this interface out over here, so blocking them from getting to this Ethernet network and this token ring network, I want to put that out over here. Okay. Whereas the extended access list has the ability to check both source and destination, where you're trying to go. To verify our access lists, a couple different things that we can look into. I can look at where those access lists are placed. If I look at every single individual interface, I can do a show IP interface and then the interface name. Okay? Now whenever you look at this, it's giving me layer 3 information about the specific protocol of IP version 4. And we get to see in this case on Ethernet 0, I've got an access list. They show the outgoing access list not set, so there is no outbound access list. But there is an inbound access list. The inbound access list is access list number 1 that we've applied to that interface. And another thing that you can do is you can actually look at the access list as well. If I do a show IP access list 101 or show access list 101, it'll show you all the different statements in the access list, so who you're permitting, who you're denying. One thing that this doesn't show, you'll also see matches within here as well. How many packets has matched each individual line of that access list? So we can kind of determine how many packets are we throwing away, how many packets are we receiving that are telnet traffic or SSH traffic. So you'll be able to see what we're actually matching and throwing away. That's pretty much it for part 1 of filtering under Cisco iOS.